Hi children and viewers. In this video I am going to discuss one of the most important topic for intermediate public examinations. At the same time, the same topic is important for other competitive exams. Okay children, చాలా ఇంపార్టెంట్ క్వశ్చన్, చాలా ఇంపార్టెంట్. ఫస్ట్ నుంచి లాస్ట్ వరకు స్కిప్ చేయకుండా చూడండి. చాలా ఇంపార్టెంట్ క్వశ్చన్. That is, in our textbook that should be mentioned as short answer question number 8. Why pulling the lawn roller is preferred in pushing it? Why pulling the lawn roller is preferred than pushing it? ఒక లాన్ రోలర్ని పుల్ చేయడం ఈజీ దేనికంటే పుష్ చేయడం కన్నా. వై? That is the we have to discuss. Children, generally tell me now, when we have some sandy floor and when we have some concrete floor, where we can walk very easily? On concrete floor. In sand the friction is more. Where the friction is more, then the motion is very less. That means what I have to say, because in the same example, concrete floor and sandy floor, to walk in the sandy floor we have to apply the more force to move. On concrete floor we have to apply the less force to move. What is the reason? In sandy floor friction is more. When friction is more, the motion is less. Clear? Like that. Here lawn roller means what? Which can rolls over a surface. That should be called a roller. We are talking about the roller means what? That belongs to which kind of friction? It is static friction or kinetic friction or rolling friction? Absolutely rolling friction. Clear? So in previous videos I clearly explained about the types of friction and cause of friction and advantages and disadvantages. So you must watch them. Okay children. So lawn roller అంటాం, మీరు చూసే ఉంటారు. లాన్ రోలర్ అనేది ఏమవుతుందంటే పార్క్స్లో యూజ్ చేస్తారు. ఆ గ్రాస్ని ఏవైతే ఉంటుందో దాన్ని లెవెల్ చేయడానికి ఒక రోలర్ ఉంటుంది. దానికి ఎలా ఉంటుందంటే హియర్ this is the one roller. For that one handle it is there. They will pull like this. When it is moves over a grass, the grass should be gets compressed and thus becomes level. క్రికెట్ మ్యాచెస్లో కూడా మీరు అబ్జర్వ్ చేస్తుంటారు. ఒకసారి వర్షం వచ్చిపోయిన తర్వాత ఏవైతే గ్రౌండ్లో గ్రాస్ మీద వాటర్ ఉంటుందో దాన్ని అబ్జర్వ్ చేయడానికి ఒక లాన్ రోలర్ని తీసుకొస్తుంటారు. దాన్ని మీరు చూసి ఉంటారు ఈజీగా ఇలా ఉంటుంది. సో బట్ ఇన్ క్రికెట్ గ్రౌండ్ దే సమ్ ఇంజనీర్ ఈస్ దేర్. క్లియర్? సో లాన్ రోలర్ అనేది ఏమవుతుందంటే ఇట్ ఈస్ ద లైక్ ఏ రోలర్ ఈస్ దేర్. సో దట్ షుడ్ బి హ్యావింగ్ సమ్ హ్యాండిల్ ఇట్ ఈస్ దేర్. Clear? So here to move the roller, which method is better? Either it is pulling or pushing. That's the topic for this video children. Clear? Watch the video up to last and you must pay attention on the topic. So clear children? First thing, what's happening when we are pushing the roller? Let's go for that. Clear children? First thing we have to observe where we have maximum friction, where we have minimum friction. That means in which case we have more friction on the roller, in which case less friction on the roller, we have to discuss here children. So first thing is here pushing the lawn roller. In case of pushing the lawn roller, so children, just we are taking the edge of the roller as like that should be seems like circle, and here what are doing? Pushing means that is what we have to push the roller from back side. That's why here if you can take like this, what we are applying force, that should be acts in this direction. Clear? So this is the direction of applied force. Direction of applied force. That's why simply here I am keeping this is F. Clear? To push the vehicle or to push the any object, we must be push the vehicle from the back side, like that. While we are pushing the lawn roller also, then here we are applying the force in this direction. So it will make some angle theta with the horizontal, and now this is the one of the component of force, that is F cos theta, and this is now F sin theta. What is that? F sin theta. Clear, children? So when it is on the ground, there must be here, what you have to say, when any object is on the ground, on that object, there must be here normal reaction is there. Children, in previous videos I explained about the normal reaction. So when normal reaction is there, that should be balanced by the weight. That should be balanced by the weight. Clear, children? Simply here we are taken, this is the roller. When the roller is on the ground, there are some two forces acting on that one. First one is normal force in upward direction, and weight should be in downward direction. When no one is applying on the force on the roller, in vertical direction normal force is there, in downward direction weight it is there. Clear? Now what I am telling, children, now at this point we are pushing the roller like this. So this is now applied force what we are using, and if you can take this is the horizontal, it will make some angle theta. So that's why the force what we are applying, that should be divided into two components. One is F cos theta, one is F sin theta. Clear? One is F cos theta and one is F sin theta. F cos theta is in horizontal direction, F sin theta is in vertically downward direction. The same thing is here. So children, diagram ardhamaithe meer derivation easy ga cheyagalutaru. So that's why we have to focus on the diagram very carefully. Clear? When we are taken one part of the roller, that should be the end what we are finding in real life, that should be like in the spherical shape. Clear? During that, what I am telling, before going to applying the force, the roller having two forces. One is normal reaction in upward direction, and next one is weight is in downward direction. Mg is here weight, N is normal force. After that, what we are discussing, we are going to push the roller. So in this direction we are pushing, then that amount of force should be resolved into two components according to the resolution of vectors. Clear? So, and now here when we are pushing from back side, the roller will move in the direction of F cos theta. In the direction of F cos theta, then there is some frictional forces acting, that is Fr. What is that? Fr. We are pushing the roller from back side. So in what direction we are pushing? In particular direction there should be moves. Clear? In opposite to that, some frictional force will be there. Clear? That's why, children, here I am showing that this Fr is the frictional force, and this Fr and F cos theta both are in opposite directions. Children, in this case you have to find when it is at rest position. What we have to say, the upward force is equals to downward force. Clear? When here, tell me now, this is the roller now, upward force is acting and downward force is acting, but the roller is moving in this direction, in horizontal direction. That means what? There is no net upward force in vertical direction. Got my point? On the roller, normal force is acting upwards, F sin theta mg acting downwards, and F cos theta is horizontal, and in opposite to that some frictional force is there. Even though so many forces acting on the roller, what we have to think, there is no motion of the roller in vertical direction. Generally what we know, children, when there is any net force is there, the object will move in the direction of net force only. That's why here the roller is moving in this direction. Clear? It means that there is no net force in vertical direction. Clear? ఈ రోలర్ మీద ఎన్ని ఫోర్సెస్ పనిచేస్తున్నప్పటికీ కూడా రోలర్ అనేది హారిజంటల్ డైరెక్షన్లో ముందుకు వెళుతుందని చెప్తున్నాం. అప్పుడు వర్టికల్ మీద ఎటువంటి ఫోర్స్, నెట్ ఫోర్స్ లేదు. దట్ మీన్స్ వాట్? నెట్ ఫోర్స్ ఇన్ వర్టికల్ డైరెక్షన్ ఇస్ జీరో. దట్ మీన్స్ దట్ upward force is equals to the downward force in vertical direction. That's why here, children, I am going to write, so in vertical motion or in vertical direction, we will consider what's that? Upward force is equals to what? Upward force is equals to downward force. Clear? During the, you can take the vertical axis, the upward force is equals to the downward force. Here what is the upward force, children? As normal force. Normal force is equals to, and downward force is what? F sin theta and mg. That's why here I am at F sin theta plus mg. Clear? N is equals to F sin theta plus mg, and this is the equation number 1, children. And already we discussed, children, according to law of rolling friction. Already we know that, children, we know that according to law of rolling friction, what do you know? Fr is proportional to N. Rolling friction is directly proportional to the normal reaction. Children, we discussed in the previous videos laws of rolling friction. On that time I clearly explained that. So here Fr is proportional to N. Fr is what? Rolling friction. And N is what? Normal reaction. Fr is proportional to N. So children, already we know that Fr is equals to what, right? Mu r into N. Fr is equals to mu r into N. Clear? So Fr is equals to mu r into N. Now it is equation number 2. And what is mu r here? What is mu r here, children? Mu r is what? Coefficient of rolling friction. What's that? Coefficient of rolling friction. So Fr is equals to mu r into N. Clear? After that you have to substitute the N value from equation number 1. Fr is equals to mu r into F sin theta plus mg. Mu r into N. N value is what? F sin theta plus mg. Then, so this is the rolling friction when we are pushing the roller. So if you want to simplify, Fr is equals to mu r into F sin theta plus mu r mg. Fr is equals to mu r F sin theta plus mg. Now it is equation number 3, children. So after that, children, here in this case we have to go for net force. What's that? Net force in horizontal direction. Net force in horizontal direction. So here it is F cos theta, and in opposite is Fr is there. Then what do you write? Net force P is equals to what, is it, children? F cos theta minus Fr. Net force is equals to okay, children, wait 1 minute. So net force is what, right? Net force P is equals to F cos theta minus Fr. What is Fr value? This one. Substitute here. P is equals to F cos theta minus of mu r F sin theta, mu r F sin theta plus mu r mg. That means here P is equals to F cos theta minus mu r F sin theta plus of minus mu r mg. So this is the amount of force acting on the roller when we are pushing. Amount of force acting on the roller when we are pushing. Got my point, children? So this is the first case. When we are pushing the roller, the amount of frictional force for that equation is what? Fr is equals to mu r F sin theta plus mu r mg. It's clear. After that, we want to find out the net force. Here in vertical direction there is no net force because upward force is equals to downward force. In horizontal direction, what we have to say? Net force is equals to F cos theta minus Fr. Clear? So we are getting this only. Clear, children? Now we will go for, in case of pulling. Clear? Okay, children. Now we go for, in case of pulling. So in this case, the roller should be like this. So I think space is not enough for us. That's why I am checking like this. Okay, children. So again, this is the roller. This is the roller. In this case, we are pulling. How we can pull? With the help of any rod or any rope. We are like this. We are pulling like this. We have to make some pull by making some angle. Clear? Like that. That's why in this case the force acting on that one is F in this direction. So as usually that should be divided into now here two components. One is F sin theta and next one is F cos theta. As usual in downward direction weight is there. In upward direction normal force is there and theta is the angle made by the resultant vector. Clear? When children, when we are pulling the roller, here the situation is like this. Clear? Look at the diagram. When we are pulling the lawn roller, the force what we are using by help of rope, that should be acts in this direction. Clear? It will make some angle theta with the horizontal. So again as usual with the horizontal it will make some angle theta. That's why due to that should be split into two components, F cos theta and F sin theta. And already what I told you, the weight is acting in downwards and again same thing, the normal force is acting in upward. Clear, children? In this case also there is no net upward force, but there is some horizontal force. Why? Because in the case of pulling also, once we can pull the roller will come in the direction of what we are pulling. Clear? That's why here while we are pulling like this, మనం ఇలా లాగుతున్నప్పుడు రోలర్ మనం ఏ డైరెక్షన్ అయితే లాగుతున్నామో ఆ డైరెక్షన్ వస్తుంది కానీ పైకి వెళ్ళిపోతుందా? లేదు. పైకి కానీ భూమిలో కానీ వెళితే there is some force in the vertical direction. Clear? There is net force in the vertical direction, but the roller is coming in horizontal direction. That's why in this case also same thing here. Children, don't confuse here. In this case upward force, I am writing upward force is equals to downward force. Upward force is what? n plus f sin theta, both are there. F sin theta is acting and normal reaction also acting. That's why both are in same direction. When they are in same direction, we have to add them. N plus f sin theta is equals to mg. Clear? N plus f sin theta is equals to mg. That means, children, from that equation what you have to write? N is equals to mg minus f sin theta. This is the expression for now. Normal reaction when we are pulling the lawn roller. So this is equation number 3, and this is equation number 4, and now it is equation number 5. Clear? Again, as usual, according to the law of rolling friction, Fr is equals to mu r into n. Fr is equals to mu r into n. So Fr is equals to mu r into n. Clear? So again, we have to substitute the n value here. Fr is equals to mu r into mg minus f sin theta. Then Fr is equals to mu r mg minus mu r f sin theta. So this is now expression for friction while the roller is pulling. So equation number, this is now 6. And children, now we have to compare the equation number 3 and equation number 6. Clear? Both equations are represents the friction. Both are represents the expressions for friction. When we are pushing the roller, this is the friction, amount of friction. And when we are pulling the roller, this is the friction. Tell me now, in which case we have more friction? Yes, while pushing. When we are pushing the roller, the frictional force is more. When frictional force is more, due to that, the amount of force acting on the net force is decreases. For example, look here. This is some we are applying forces. For example, we are saying 30 newtons. 30 newtons. And frictional force is some here 20 newtons. 20 newtons. Then 30 minus 20, 10. Like that. So here next time 30 newtons and here some 10 newtons. Clear? 30 minus 20, here 10 newtons. Net force is what? 10 newtons. And here 30 minus 10, 20 newtons. Got my point? You have to understand this. When we are pushing, the amount of net force is very less, because in that expressions what we have, all are minuses. F cos theta is, it is acting in horizontal direction. From that we have to subtract mu r f sin theta, mu r mg. When we are taking so many subtractions, the value is less. When the net force acting on the roller is less, that should be goes very slowly. That's why we can feel it is difficult to push. Okay, let's wait. And next, children. So this is the frictional force 6 while we are pulling the roller, and in this case we will write net force. Again, as usual formula, net force P is equals to F cos theta minus Fr. Here also same thing. The roller is moving in the direction of F cos theta, and in opposite to that what we have, Fr is there. Frictional force is there. We can show here also same thing. So that's why P is equals to F cos theta minus Fr. Already Fr value is what it is here, children. Then P is equals to F cos theta minus Fr. Fr is what? Mu r mg minus mu r f sin theta. Clear? P is equals to F cos theta minus mu r mg minus mu r f sin theta. From that what did, children? P is equals to F cos theta minus, we have to apply minus, mu r mg minus of minus plus mu r f sin theta. So this is the applied force. This is the applied force. So when we are pulling the roller. Okay children, what is the question here? From these derivations, how we can say pulling is very easy than pushing? How we can say means from two equations. So once you have to observe the final equations. So this is the net force acting on the roller when we are pushing. P is equals to F cos theta minus mu r F sin theta minus mu r mg. Here minus is there, that's why the value what we are getting, that is less. And here while we are pulling, P is equals to F cos theta minus mu r mg plus mu r F sin theta. So in this case you have to observe we are adding only one minus is there, that's why here net force is more. When net force is more, the object will moves very easily. When net force is less, the object is moves very difficulty. That's why here we can feel that it is very easy to pull the roller than pushing. That's the question, children. Got my point? So in this way we have to conclude pulling the lawn roller is very easy than pushing. Very simple children. ఇక్కడ మీకు ఈక్వేషన్ చూస్తే అర్థమైపోతుంది ఏంటంటే ఇక్కడ ఎప్పుడైతే మనం పుష్ చేస్తున్నామో ఏమవుతుందంటే ఫ్రిక్షనల్ ఫోర్స్ చాలా ఎక్కువ ఉంటుంది. Fr is equals to mu r F sin theta plus mg. క్లియర్? సో ఫ్రిక్షనల్ ఫోర్స్ ఎక్కువ ఉందంటే నెట్ ఫోర్స్ వాల్యూ తక్కువ ఉంటుంది. సో నెట్ ఫోర్స్ వాల్యూ తక్కువ ఉంటుందంటే ఆబ్జెక్ట్ అనేది స్లోగా మూవ్ అవుతుంది. సో ఇక్కడ చూడండి, ఇన్ కేస్ ఆఫ్ పుల్లింగ్ ఫ్రిక్షనల్ ఫోర్స్ ఏమవుతుంది లెస్. ఇక్కడేమో ప్లస్ ఉంది, ఫ్రిక్షనల్ ఫోర్స్లో వీ హ్యావ్ ప్లస్ ఈస్ దేర్, హియర్ మైనస్ ఈస్ దేర్, దట్స్ వై హియర్ ఫ్రిక్షనల్ ఫోర్స్ ఈస్ లెస్, డ్యూ టు దట్ అప్లైడ్ ఫోర్స్ ఈస్ మోర్. అందువల్ల ఏమవుతుందంటే వీ కెన్ ప్రిఫర్ టు పుల్ ఏ లాన్ రోలర్ దాన్ పుషింగ్. క్లియర్? See once again children, very important vision. Look here, why we can prefer pulling the lawn roller than pushing, that's the question. Look here, first thing we are going for pushing the roller. ఒక రోలర్ని పుష్ చేసినప్పుడు ఏమవుతుందంటే ఈ డైరెక్షన్లో ఫ్రమ్ ఎనీ టైమ్ వీ కెన్ పుష్ ఫ్రమ్ ది బ్యాక్ సైడ్ ఆఫ్ ది ఆబ్జెక్ట్. సో ఇన్ దిస్ డైరెక్షన్ వీఆర్ పుషింగ్, ఈ డైరెక్షన్లో పుష్ చేస్తున్నాం, అప్పుడు ఫోర్స్ F. This amount of force F will make some angle theta with the horizontal. హారిజంటల్తో theta యాంగిల్ని చేస్తుంది. అప్పుడు ఈ ఫోర్స్ ఏమవుతుందంటే టూ కాంపోనెంట్స్కి డివైడ్ అవుతుంది. ఒకటేమో హారిజంటల్ కాంపోనెంట్ F cos theta and one is vertical component F sin theta. And this is the normal reaction. Clear? And weight is downwards. The roller is moving in the direction of F cos theta, that's why frictional force is in opposite direction. You can represent like this also, Fr. So while the roller is in horizontal direction, there is no vertical net force. సో ఎప్పుడైతే రోలర్ ఇలా మూవ్ అవుతుందో వర్టికల్ ఫోర్స్ ఉండదు అనుకుంటున్నాం, కాబట్టి అప్వర్డ్ ఫోర్స్ ఈజ్ ఈక్వల్స్ టు డౌన్వర్డ్ ఫోర్స్. సో అప్వర్డ్ ఫోర్స్ ఈజ్ N and downward is F sin theta is there and mg is there. Both are in the same direction, that's why we have to add them. N is equals to F sin theta plus mg, equation number 1. And already we know that children, law of friction, law of rolling friction, Fr is proportional to N. Then Fr is equals to mu r into N, and we have substituted the N value. So after that, here in horizontal direction, F cos theta is there, Fr is there. The frictional value is always less than the F cos theta. That's why we will write net force P is equals to F cos theta minus Fr. అక్కడ Fr substitute చేస్తున్నాం. We are writing the equation number 4. Next, now in case of pulling, while we are pulling lawn roller, we have to pull like this with a rope or with a rod. By hold that, then roller will comes in the direction of what we are pulling. So that's why here this is the direction of pulling F, and that force is divided into two components, F sin theta and F cos theta. Clear? So in this case also the roller is moving in horizontal direction only. That's why there is no net force in case of vertical direction. That's why children here we will write upward force is equals to downward force. In this case upward force is what? N F sin theta. That's why here upward force is N plus F sin theta, that is equals to downward force what is what? Weight. So we are equating those two. From that we write expression for N. N is equals to mg minus F sin theta. And already we know that law of rolling friction, Fr is equals to mu r N. Fr is proportional to N. From that equation what write? Fr is equals to mu r into N. Here N value is what? Mg minus F sin theta. Then Fr is equals to mu r into mg minus F sin theta. Then you will get like this, Fr is equals to mu r mg minus mu r F sin theta. So in this case frictional force is very less. In this case frictional force is more. Again as usual, here F cos theta is there and Fr is there, both are in opposite direction. In this case also Fr is less than the F cos theta. That's why what we write? Net force is equals to P is equals to F cos theta minus Fr. Then we are writing like this. So by comparing the net forces, what you have to say? In case of pulling only, we will apply the more force on the roller. That's why it moves very easily than pushing. Clear? In this way, we can prefer the pulling than pushing. So children, I hope you understand the topic. So see the video twice or thrice like that. If you have any doubt in the derivation, just go back and come once. If video మీకు నచ్చితే మీ ఫ్రెండ్స్ కి షేర్ చేయండి, ఈ ఛానల్ కూడా షేర్ చేయండి. So I hope you understand. We will meet in the next video with other interesting topic. Bye. Take care children. Keep smile, keep rocks.